Hey friends, I think we are live. Double check that audio volume really quick. Okay, hey, I'm Andrew. This is Code Gets Creative. Good to have you here. You might have already noticed some things are different with this stream from previous ones. We've swapped out the camera here. This is like kind of a not as great webcam, but it's making it work. But today, the reason we have done that is because we're not working on software, we are working on hardware. And big reveal, we've got the real cool, nice camera set up down here where we can use our soldering station. So that's what that's all about. Today on the stream, we are going to be working on this. So this is a DIY kit for a Eurorack synth module. Now, I know I might have like some synth folks and some software folks on the stream, so let me explain what I'm talking about here really quick. You can see back here we've got some synthesizers set up. This guy up here with all these cables plugged into it is a modular synthesizer. And instead of being a single box where you twiddle some knobs and it makes all the sounds kind of in a like straightforward kind of a way, instead the box is made up of individual modules, and each of those modules does one thing, and then you patch from one module into the next in order to program sounds. They come in all different shapes and sizes, they do different things. So today we're going to be making another module that's going to go into there and is going to be like a boring module, but a very useful utility module. So the name of this module is the Synthrotek brand MST-07 buffered multiple module. Now, what that means is basically we're going to have some audio jacks over here. You see everything that's highlighted in black right here is an input. So basically sound will come into here, or control voltage will come into here. And then it's going to get copied and pasted from these inputs into these other outputs. And the reason that's useful is because sometimes you end up creating signals in your synthesizer that you want to send to a few different places. And so being able to copy and paste like this lets me say, hey, I'm going to send in some pitch information, play a low note and then a high note, etc. I'm going to plug that into here, and then I can copy paste that into here so that I can, instead of just having one oscillator generate a waveform in my synthesizer, I can have 2 or 3 or 4 all following the same pitch, and I can create like a mega oscillator that way. So that's what this thing does. This is maybe a good opportunity to talk about this other little guy. We can get the camera to focus. This is also a multiple module. That is not focusing. So this is also a multiple. This is by a different company called Pittsburgh Modular. But this one is passive, as opposed to this one, which is buffered. What that basically means is that this passive synth module right here, it doesn't have a power strip that actually plugs into power, but this one does. What that means is that this one's really cheap, really simple, and it's good for things like metronomes or gate signals, where you can basically say it's on or it's off. But it's not very good for sending pitch information. And the reason for that is because every time you send in a signal and then send back out, you might draw a little bit of current from each of these. And that changes the voltage that's coming into here. In other words, the voltage sags. It'll droop down just a little bit. And what that means is that these outputs are a little bit less accurate. Now, for a metronome, that doesn't really matter. Like, it's basically a high voltage or a low voltage. And as long as it's high enough, boom, that's still a metronome. It's still on. It's still like considered on by the synthesizer. But with pitch information or some other kind of information, it's a little more granular than that. As soon as the voltage sags, this is no longer accurate enough to be usable. And so we need a different kind of module like this that plugs into power and uses operational amplifiers or op amps to buffer the sound so that what you get in is what you get out. And you know that it's going to be accurate, like accurate enough to use for control voltage or audio sorts of applications. So that's what we're building today. Let's see, a couple other things we can talk about before we get started. Yeah, here's the DIY kit. It's got cool stickers in it. We'll open this up in just a minute. We've also got a lot of other things sitting around. These are all like tools and equipment that we're going to be using today. So here is a soldering iron. This gets really hot. It's going to be about 700 degrees Fahrenheit. And that is going to connect to this, which is my my solder wire. And that's going to get heated up really hot, and then it's going to be applied to the circuit boards in here, and we're going to connect components to it, and boom, it'll become permanent at that point. In case we mess up, here's some desoldering wire. It's really useful for cleaning things up if we make a mistake. This is a multimeter, which can tell us things like, is there really a connection from point A to point B? Or is there something wrong with that connection? And how much resistance, basically like if current's going in, is some of that flow being stemmed by components, or is it all getting through, right? This can tell us stuff like that. And then we've got things like, wire snippers. We can snip stuff. This also can strip wires that have like rubber shielding on the outside. They're very useful. And then a set of pliers for like moving stuff around. Yeah. Some other things that are useful in general for creating things are breadboards. So this is called a breadboard, and this is a circuit board where instead of looking like this, where maybe I should actually open this up first. Let's do that, and we can kind of compare and contrast like these two things with each other, and then we'll talk about this guy as well. Okay. Here comes the unboxing. So yeah, here's the kit. It's like stapled right here. Let's pop these off. Here we go. Pop that off on both sides. Synthrotek, classic noise. There's like this cool, like zombie astronaut. Dig that. And then inside of our kit, let's have a look at what's inside. We'll start with the swag, of course. So we've got, Synthrotek, classic noise. Cool, it's got like support information. And I have had great luck with this particular company, Synthrotek. They're awesome. They make really good stuff. Haven't had any problems with it, and their instructions are good. The reason I bring that up is because you see this big synth in here. There's a whole bunch of modules. There's a couple dozen in here. This thing would cost double what it does if I had not done as much DIY as I have done. In other words, I've bought a lot of these kits, and it's cheaper to buy them in this form than to buy them in like the completed form, because then you're paying for like the cost of somebody else to put this together, and there's kind of a markup for that. So if you want to get into this stuff, you want to play modular synths, but you know that it's quite expensive to just buy the pre-built stuff. Look into DIY like this. The kits are much cheaper, often like half the price, and they often come with very good detailed instructions that'll help you put them together. And then I think like maybe you've heard of the IKEA effect before, but that's definitely a thing. Basically, the IKEA effect says that if you put something together, or if you work on a project of some kind, then you value it higher. Even if you had purchased something that's the same price and higher quality, you value the things that you work on and that are like your projects. So that's really cool. Like I'm really happy about like all the cool DIY stuff that's in here, because like I played a part in this. I wasn't just a consumer. I was also like a creator in some small way. But that also brings me to this other module that I have sitting here. And this guy, let's see, let's move some things out of the way. This doesn't look as cool on its faceplate as this like designed, Synthrotek module looks. They've got their nice like silk screened aluminum panel. This one's a DIY project by yours truly, but the special thing about this was not a kit, and in fact, it wasn't even made by. It wasn't designed by another company. This is all my work. So this is called the Rhythm Quantizer. So I designed all of this. I bought all the pieces, and I put them all together on these boards here. Let's see if we can get this to zoom in. These. Come on, camera, let's go. Yeah, so you can see we've got these boards here that everything goes on. They're all numbered and lettered, which helps me keep track of where everything should go. And it's actually very similar to a breadboard. There are a whole bunch of circuits that are kind of connected underneath each of these rows. In other words, like, let's see, I need like a pointer. In other words, like this whole row of little insert holes right here is all connected. And so is this one and this one and this one, so on and so forth. And that helps me prototype. It's actually the same idea here, where, come on, let's focus. I've got to just change my camera settings to not autofocus. Maybe that's what I need. But you can see each of these is the same way. Like each of these connections behaves the same way. So I can prototype it on a breadboard and then put it here on this Autos DIY board, which already fits synthesizers, like it's the right width and height to fit into a Eurorack. Drill some holes and everything works. So yeah, this has been awesome. It's been very rewarding to not just build kits and implement other people's designs, but actually come up with my own. If you want to learn more specifically about this module, I do have a YouTube video, so check that out on my channel, and you can learn more about like what it specifically does and hear it being used in a synth patch. So that's really cool. I'll move that over there. And you can expect some more of this type of stuff in the future. Here, this is a little chip right here. It's called a development board in general. And more specifically, this is called a Teensy 4.1. So Teensy is a brand sort of like Arduino, if you're familiar with that. It's a microcontroller. So you can plug right into this USB port and send code to it. And then you can interact with actual hardware and stuff. So this is a great brand and great chip to work with. I used a similar one to build this little guy. You can see the little green chip in here. This is a Teensy LC, but this is a little macro keyboard that can like play and pause music and can mute and unmute Zoom, actually, like mute and unmute my microphone when I'm on work meetings. So this is like really simple, but super useful. I use it every single day. So this is cool. We might talk more about these types of projects. The other thing though, let me grab this board to show you. This is one that I'm very excited about. This brand is called Electrosmith. They're a pretty new one. They launched on Kickstarter. They launched this project on Kickstarter just a year or so ago. This is called the Daisy. You can see this chip right here. And they've got this like kind of bigger development board that it plugs into. But this is a microcontroller specifically designed for audio applications. So this is the main CPU, but then this is the audio board, or the audio codec board, which is really good at like converting really high resolution inputs and outputs. So you can actually do whole digital effects. You can build guitar pedals out of these. You can build synthesizers and synth modules out of these. Super excited about like all the potential that's in this. It's pretty new, and so I don't know if there are a lot of other companies that have already like launched with professional gear that is built with this. But it's definitely starting to build kind of a community of like prototypers and DIYers. And I'm excited to do some of the same. Like I want to design a couple of Eurorack modules that use this as kind of its brain. So that should be really cool. Set that aside. So I think without further ado, we're ready to actually get started on this module. So yeah, let's keep going. We've got our zombie astronaut. I guess it's a zombie cosmonaut, right? Because we've got like the SSSR, the Soviet Union helmet, kind of great. Synthrotek skates. I'll have to put it on the skateboard that I don't have. I don't skate. But yeah, okay. So we got all this stuff. Let's get some of these other things out. We've got so these green boards right here. These are called printed circuit boards, or PCBs. Looks like this is the top one. This is the bottom one. How do I know that? It's because this particular one has all these circles on it. This is where all the jacks are going to go. And so this is going to line up really nicely with this faceplate. It's going to go right over the top. And then all the logic is going to live on this board down below. So that's all there, and then they're going to like pop together. It's going to, let's see. If I zoom in a little bit, hopefully you should be able to see that just fine. Each of these boards in here, let me bring my microphone a little closer. Hopefully you can hear me just fine. So each of these boards has all of the electrical traces, right, inside of these. So each of these holes is going to connect to whatever it needs to. We just have to put the components in, and then boom, it's going to do its thing. You'll notice though that it's also got room like right here. Oh, sorry about that. I'm like not even in frame. Awesome. So you notice like all these leads connect, but then you'll notice that like there are these little outlines here. This is where the power supply goes. This is where one of the integrated circuits goes. It's this little black chip. Another one goes here, another one goes here, another one goes here. So you can kind of like, the PCB actually helps us to know where things go. And we've got these instructions here, which we're going to look at in just a sec. But this is going to be kind of the second way of like double checking that we're doing the right things and that we're putting all the components in the right places. It can feel kind of intimidating at first, like if you've never seen one of those. The instructions are super helpful though, and you'll start to see that there are conventions that help us to make sure that we're doing things properly. Okay, yeah, let's see what else is in the bag here. Let's see, zoom back out again. So, also in the bag, these are some really critical pieces. These are fundamental components that are called resistors. These are the little blue guys with the stripes, and capacitors. There are a few different types of capacitors. These are electrolytic, these are ceramic. Oh, there are also some diodes in here. These are some of the like building blocks of electrical circuits. There might be some transistors floating around as well. We'll see. Transistors are the building blocks of digital computers. Okay, and then there's also some hardware, right? Like you can see these are metal standoffs that will help position these PCBs apart from each other, just the right distance. And then some screws that'll let us connect this module in with the rest of the rack. And that's going to go here and here. Okay. Let's see. Next, we've got a whole bunch of these jacks, right? These 3.5 millimeter audio jacks. Each of these is going to go in here. A whole bunch of them. We've got our power strip. This is specific to Eurorack, right? But this part goes into the module. You remember this right here that's going to go right here, basically. And then the other side plugs into the power supply in the case. So here's what that looks like on my rhythm quantizer. You can see it goes right there. Looks a little bit different. Like mine has all the leads on it. This is a simplified one. You can look up the Eurorack details to understand more about that. Yeah. And then let's crack this open as well. This is where all the integrated circuits are going to live. Cool. Those are all right here. Let's maybe zoom in on that as well. So what you can see here, we've got these 1, 2, 3, 4 different ICs. They're going to snap into these, which are sockets. Basically, these are a little fragile. They can be damaged mechanically, like if I put them in wrong. They can also be damaged electrically, and I believe they can actually wear out over time sometimes. So basically, it's good to be able to replace these. And so these sockets make it easy to do that, where we actually permanently solder these sockets into our PCBs, right over here. And there's like a spot here, for example, to put one in. So we're going to permanently put in the sockets, and then these ICs are going to snap in. And if we ever need to, we can pull this out with some pliers and then replace it with one just like it. And if we look really closely, you know, maybe that'll focus, maybe it won't, whatever. They're numbers and letters. They're like serial numbers on each of these ICs so that we know what model number they are. And so if we ever do need to replace them, we can do that. Okay. Let's look at the instructions next. Zoom back out. And I think let's move some of this stuff out of the way as well. And I'm also going to be putting some of this stuff back in because we're only going to need a few, like some of this at a time. So put that back on. This is the most expensive. These are the most expensive pieces. So as well. So we want to kind of keep these safe. Okay. Put these back over here. So here's what the instructions look like. Oh, okay. So it's just a bill of materials. There are probably instructions online, although honestly, I'm not too worried about it. Yeah, in fact, we might not even need instructions at all. So yeah, let's walk through what this bill of materials actually includes. Here are the resistors, diodes, capacitors, right? We talked about those in this smallish bag. We looked at the integrated circuits with their sockets. Here are all those jacks. These headers plug in the PCBs to each other. Standoffs, screws, and then we've got the base plate and the PCBs and the power cable. Cool. So we saw all this stuff in there. And yeah, like that's it. Now, this has actually been different from some of the more maybe complex modules that I've seen, where it actually did come with like 3 or 4 pages of instructions to kind of walk you through. However, I think we can do this just what we're looking at here. No, let's go to the website too and just double check that they don't have anything special. The thing that makes this doable is notice how each of these different parts, even if it looks similar, it's actually labeled like where it goes. What I mean by that is there are all these different resistors here that are 1 kilo ohm, right? 1 k ohm. And there are these other ones that are 100 k ohm. So they look super similar. So what, how do we not mix them up with each other, right? You see this like R1, R3, R5, etc. Those are actually silk screened onto this PCB. So let's get that out really quick. And I think we're going to want to start with this one anyway. So we've got that here. And notice how, yeah, there's a whole bunch of them right here. So we've got like R7, R9, R11, R13, R15, R17. And over here, there's another chunk of them. And it looks like R2, 4, 12, 13. Where are those? Where do those look? Okay, so here's R2, here's R4. Not to be confused with Star Wars. Here's R12. And then let's see, R13. Yeah. And yeah, hopefully you can see that well enough if you're watching in HD. We know where each of these goes based on these silkscreen labels right here. So that's cool. The other thing, let's see, are they separated from each other? Hopefully they are. That'll make our lives easier for sure if they have already been kind of separated apart. Yeah, it looks like all the 100K resistors are right here. Now, let's zoom in again and look at that. So here are resistors and capacitors and diodes, right? Notice how, let's see, notice how they've all got these stripes on them. They have different stripes. And different colors of stripes actually tell us how resistive each of these are. And let's see, I've actually got a little book of resistors that I bought online that makes it really visually easy to see what those are. So let me grab those really quick. I've got those in a box down here. So this right here, if I zoom out a little bit, this is a resistor kit. You'll notice I bought it from SparkFun Electronics. Really awesome online store and online like set of tutorials that can help you get started in electronics. So this resistor kit is just a couple dozen, well, probably like 20 or so of each common type of resistor. So you can see there's just pages and pages of these. There's a few hundred total. You'll notice they've also got them kind of labeled here, which is nice, but you can see that there are different colors of stripes. Those colors of stripes show up on the back. By the way, notice how the body of these resistors is blue, the body of these is beige. That's because these are not quite as accurate as these. So when you're doing analog electronics and you're trying to make your synthesizer be perfectly in tune and behave exactly how you expect, you want to use more accurate resistors, which costs a little bit more. So that's why these are blue. They're colored to show that. If you're doing just digital electronics, this is a little bit less accurate, but it doesn't really matter. The tolerance is a little bit higher, but that's totally fine. You can see I've used a ton of this variety. What is that, 1K? Yeah. Okay, anyway, here is the color coding that shows you the value of each resistor. And I think you can look this up online as well. Just type in like resistor color codes and you'll be able to see this same chart. But essentially, each of these colors represents a number, like a different digit. So you see how like black is 0, brown is 1, red is 2, etc. And so if you look really closely at these and at the stripes, you can match it up with this and figure out what value it is. The other thing that you can do is you can use a multimeter, right? And put it into resistance mode, hold it up to the two sides of your resistor, and the number here should be very, very close to whatever this color code is. Might be off by, plus or minus 1% or whatever, but it should be very close. And so this is a good way to kind of double check that the resistor really is what you think it is. All right. So yeah, we've looked at everything that's in the kit. Now let's go find the instructions online. And I believe I looked them up the other day, and they were pretty minimal. But they do help with the sequence of like which parts do we do first. So let's check that out next, and then we can get started. Let's see. Switch over to this. Yeah, by the way, here I am on sparkfun.com, where I bought that resistor kit. They've got an online store. There's tons of stuff in here, and it's all very beginner friendly. There's also a website called Adafruit, which is also for hobbyists. They've got all kinds of cool stuff like in their shop, and great tutorials. I've had really good luck with theirs. And then there's also like Mouser and DigiKey, yeah. There, we'll let them pay for an ad click real quick. So Mouser and DigiKey, these are not quite as beginner-friendly websites, but they are enormous catalogs of like every electrical component you could ever imagine. And so you can search for them on these websites. I've bought things off of all 4 of these websites, so these are good bookmarks to have. If you're a hobbyist just barely getting started, I definitely recommend like start with SparkFun and Adafruit. They're both amazing. And then as you get more comfortable with things, you can start buying in bulk or more esoteric things from Mouser and from DigiKey. Okay. Let's see. I think this is our friend that we're looking for. So here's the completed module right here. You can see all those jacks like screwed into the faceplate. Talks about what it does. We already talked about that stuff. There's video, another video. Somebody was like, I want to convert this to a totally different modular format. Kind of fun. Okay, but we want to go to assembly instructions. There we go. You will need a micro Phillips screwdriver to assemble this product. Cool, we're in luck. I got one over there. So let's see. Got the panel. Thanks for purchasing it. Yeah, this claims it's an intermediate build. There's some stand-up resistors. Components crowded together. That is true. Yeah, I'm not worried because I've already done several of these. I think maybe it might not be a great first build, but yeah, I think you can still do it, and there's like plenty of other DIY kits that that'll like help you through it and are maybe a little bit less crowded than this. All right, we know we have all the right stuff. So here we go. Main board, it says start with the diodes, then the capacitors. Huh, I'm surprised. Okay, then the resistors after some of this other stuff. Okay. Well, yeah, let's get started then. Start with the diodes. All right. Now, notice this right here. Start with the diodes as shown below. You can see them kind of in this spot. Carefully flip them over on a firm surface to solder. Clip your leads. Diodes are polarized components. That's really important. So you must match the black stripe on your diodes with the white stripe on PCB silkscreen. In other words, if you put these in the wrong direction, your circuit is incorrect and it could burn up or it could damage other things. So it's really important that we get these facing the correct direction. Okay. But yeah, let's switch over here. I'm gonna turn on my soldering iron. Wait, am I not plugged in? Oh, shoot, I'm not plugged in. Give me just a sec. go. It has turned on. And we will set that to exactly 700 degrees Fahrenheit. And you can't, okay, yeah, you can kind of see the 700 on that little 7-segment display. So this is now at temperature. This is very hot, so we have to be careful. Note about soldering irons. Mine's a nice one. It's probably around $50 or $60. You can get started on a cheaper one though for probably like $10, $15, something like that. And that's kind of your very first tool for getting into this stuff. So get a simple soldering iron, and then get a multimeter and get some of these other simple tools, and you'll be off to the races. Okay. Let's move some of this stuff as well. Set some things on the floor. And let's see. So here are 4 little diodes. We're gonna be starting with this PCB. So I've got it oriented the same way as this. Let's load this up. You can see how there's like an IC over here, IC over here. Diodes go kind of top right. Here's the power in the bottom right. So, oops. So right here, we've got IC, IC. Here's the bottom right power supply, and then the diodes are going to go up here. Okay. Let's see, and I am just match the black stripe on your diodes. I'm always like kind of paranoid about, like, even though I've done this several times, I'm just worried I'm going to do it the wrong way. So it's always useful to double check the instructions and make sure that okay, you can see that white stripe right there. So what I'm going to do, get these kind of started by hand. Put it right in here. And I like to kind of finagle it in a position. Pliers are good for this part as well. Yeah, that first one is in there. Let's do the first one and then we'll do the other 3 together. So, like that, yeah. Click the picture, flip it over. What we're gonna do is, where's my solder? Here it is. What we're gonna do is, we're gonna get a little bit of solder right in there. Heat that up until it looks kind of like a volcano, and it cools very quickly. And then once that's done on both sides, we'll snip off these leads. There we go. Okay, here's the tip of our soldering iron. Once again, it is hot. Need to get a little closer to my work. There we go. So you can see how, hopefully you can see that just fine. We're heating up the solder, and so now there's this little gob of solder on the tip of the iron. I'm gonna clean this off. This is a good thing to do when you first get started on a project, is you want to clean the tip of this by getting solder on it and then cleaning it back off again. So this is good and hot and clean now, and we're ready to solder those 2 leads. So let's go ahead and do that. So this one up here, I'm gonna heat up the component just a bit. And then I'm gonna feed some solder into it. And there we go. And it has turned into a volcano. And then I'll do the same one here. go. No, you might have noticed I fed a little bit more into it, and then finish that off. Okay, clean the iron and then put it back in there. Let's look at what we just did. If we zoom in here, you can see our two leads. Is that focusing? Kind of. You can see our two leads. We're making our volcanoes right there. And those are nice clean solder joints. So that's in there now permanently. And now, take our wire cutters. I don't usually use this pair, man. I'm kind of worried about it. What about, I don't usually use this one either, but it's like a little closer. So notice how you can like snip a wire down here, or you can just move stuff around. Let's just go right there, snip, and it comes right off. And right here, snip, and that other lead comes. Okay, we're not getting those quite down as far as I would like, so I'm actually going to get out another pair of wire snips. Oh, seen on chat. Any chance you could zoom in a bit more? Yeah, for sure. Thanks for calling that out. Okay, so it looks like this is as far as I can zoom in. Let's see. I can also lower the camera just a little bit, so let's maybe do that. Start right here, and a bit, and then I will very carefully lower this down further. You can see my light right there. See. Here we go. So now I've got a little bit more like headroom. Back. Is that looking okay? Yeah, I think that should work. Yeah, please let me know if you're having a hard time seeing things. Okay, looks great. Thanks. Awesome. So, yeah, once again, these, and I should zoom back in for this stuff, but so once again, we've got these. Oh, we've got these leads right here, and we've got these kind of like kind of cone shapes to get formed. If your solder is not quite hot enough, or you don't feed it enough, these will end up kind of bulging into different shapes. So watch out for that. These two look good though. Cool. All right, give me just a second. I'm gonna grab my other wire cutters, and then we can do those other diodes. Yeah, right in here. This is all the soldering equipment that I was not sure whether I would need or not. All right, so let's switch back over. So I like these other wire cutters because you can get like really down in there, close to the part. Okay, so let's go ahead and do those other diodes. Got those right in here. Flip that over and pull these out. Let's just pull them out one at a time. And then I want to orient them the same way, right in here. One trick that you can do is like let your PCBs do some of the work of moving them into place. Okay, so that one's in there. I'm gonna bend these leads outward just a little bit, and that way it stays in place even though it's not soldered just yet. And then I'm gonna grab these other two and do the same. Get that one in there. Got a little messy when I bent it. Oh well. Okay, so that's in there. Bend the leads to keep it there. And then that last diode. I think we're gonna see, since there's kind of 4 different mini circuits in this, we're gonna see a lot of like 4 of everything, or multiples of 4. And okay, so that's in there. Got the leads there. They are all ready to be soldered. You don't have to do 3 at a time if you're less comfortable with that. Definitely just do 1 at a time. But yeah, as you get more comfortable, you can start doing multiple at a time. Here we go. Heat that up. And some solder. And boom. A nice cone shape. The other side. Heat that up. Whoa. Now you might have noticed the solder wire actually got stuck permanently to the lead, so I had to heat it up again so I could pull it back off. You'll see that sometimes. Yeah, solder wire is really cool, really interesting. Like it heats up very quickly and it cools off very quickly. Yeah. I'm soldering in kind of a funny position since I'm trying to stream this, so I'm shaking just a little bit as I go. Pardon the shakiness. All right. So we've now got, and what I'm doing here now is I'm inspecting each of these, making sure they look clean. This one's doesn't have a ton of solder. But it's still like a clean solder joint, so we're fine with that. Okay, so I'm gonna put that down there. Grab my wire cutters, and then snip, snip, snip. And you can see how I'm doing kind of assembly line style since all 3 of these are here, right? Like, when you start doing multiple at a time, it's a little easier to like, you know, cut off all these component legs at the same time. Okay, so our diodes are finished and looking good. You can see them right there. And if I switch back over to the instructions, boom, here it is there. You can see how that looks similar. So we're off to a good start. Okay. Next step in the instructions is capacitors. Let me just make this a little bigger. Okay. The ceramic capacitors are not polarized, so it doesn't matter which way you orient them when populating them. That's the little beige, a little brownish, tannish colored capacitors. So that's this one and this one. Okay. Next are the electrolytic capacitors. These are polarized. Okay. The longer of the 2 legs is the plus, and the stripe should be facing away. Cool. Yeah, so let's do the ceramic capacitors next. Zoom back in again. I've got my two ceramic capacitors here. And let's see, remember those are not polarized. They're fine on like putting them in either direction. Now notice on our instructions that these are labeled C1 and C4. And I'm double checking that because I want to make sure that we're putting them in the right place. So here's C1, here's C4, perfect. Put that in. Bend the leads so that it stays put. And put in the other one. Bend the leads. Sweet. What I just did there is called reflowing. Basically the solder got there, but it was a little too cold. And so it didn't make that cone shape like I wanted to see. So I got it hot again and I fed it just a little bit more and that cleaned it up. Just reflowed that one as well. Okay. So yeah, those look clean. Snip off the legs. All right, so those look good. Now let's do the electrolytic capacitors. Okay. You guys don't want to come out. Okay, so let's double check this again. The longer of the two legs is positive, and then the stripe is the negative. You can see those right here. Switch back over to here. So here's the stripe. Here's the stripe, that's the negative side. And then the rest of the black area is positive. Notice the longer leg as well, so that also signifies that. Okay, and you can see a little plus sign right here. So we fit that in there. And it looks like it doesn't quite want to go because these legs are bent outward. So we're gonna have to finagle these into place just a little bit. So we're gonna very carefully bend them into the shape that we want. That's closer. And we want it this direction. I'm just gonna, there we go, just push it a little further. It's not quite, it's not flush. Oh, sorry. It's not flush with the board exactly, but it's pretty close. And then all these ICs are gonna be kind of tall as well, so that should be fun. At least I think so. I guess. Oh yeah, because this is where the power goes. So in other words, this is going to be oriented like this. All of these components are going to be facing down into the case rather than up towards the other circuit boards. So it's okay for these to be a little bit tall. Okay, let's do the other one now. So I'm bending those into shape. And then flip that around. This is gonna go in here. Notice how they're both facing the same direction. Push that kind of in place. That looks like that. Cool. That can lay more or less flat on the table now. I'll go ahead and solder that. Notice how I've got one finger kind of resting on this. So I can kind of keep it steady. Done. Flip the board around. Oh. A little teeter-totter going on. There we go. Had to reflow that a little bit, but that looks clean now. And we'll get the other side. Sweet. Okay, and then there's a little glob on the tip of my soldering iron, so I will clean that off in that wet sponge. Okay. We've got our leads there. Yeah, those look clean. All right, we got this all cleaned up now. All right, on to the next step. Let's see. So we just did the capacitors. Next up are the IC sockets. Yeah, pay close attention to the half moon looking notch on one side of the socket. So you can see there's like one there, one there, one there, one there. Carefully flip your project. Yeah, that's fine. Okay. Sweet. Notice how this is kind of talking about like start by soldering only one leg of each socket. So in other words, we're going to do like the bare minimum to keep it kind of glued into place, and then we'll get everything else into place. That's the idea there. So we'll orient this the same way as the instructions. We need to grab the IC sockets out of their little house. Okay, these are the same dimensions. Yeah, it looks like these three are. And then there's this fourth smaller one. Cool. Okay. Now the sockets are interchangeable as long as they're the same size. The chips can sometimes be different though, even if they're in the same physical, like they're the same physical shape. They might still have different electronics inside. So it's important to double check the ID numbers on those. Okay. Notice the little half moon notch right there. There's also a half moon notch on this side of the IC. So you can see that okay. Yeah, so we'll put it in there. And those tall capacitors are going to make it a little bit harder. Let's see. One thing that I have done in the past is here's some electrical tape. You can actually kind of tape them into place temporarily and then remove the tape. So grab a little bit of tape. Make sure it's oriented correctly. Pulling that tight, and there we go. So that's very, like, it's snug enough to be in place. And I still have access to this corner and this corner. So I'm gonna solder just one of those, and that way it's gonna stay in place, and I can pull the tape back off to do the rest. All right, so we'll do this corner here. Get it a little hot. Feed it some solder. Oh, okay, so notice how it kind of fell out, like they didn't quite work. So I'm gonna do, there we go. Push that back into place. Let's see, there's one socket in here. Oh yeah, that. Yeah, I think we'll fit in its little house. Okay. Yeah, that's looking good. So we've got our one corner done, and now we can go ahead and do the rest. So, do a little guitar thing. We got that one. Often with these IC sockets, I like to skip every other lead and then go back and do them. That way I'm not applying like too much heat to any one part of the board. That's just kind of an extra precaution. Go. There we go. Okay, so we've done every other lead on both sides. Now we can go back, because at this point it's kind of cooled down over here. Now we can go back over it. Okay. There we go. That IC socket is complete. Got that there. There's just one of these little tabs that sticks up a little higher than the others. I think that should be fine though. And if we really have to, we can desolder this and push it back down. So we will see. Okay, let's do this one next. Got my next socket. Get it positioned correctly. That half moon is lined up. You know, maybe we should do this instead. I'm gonna zoom back out. Notice how my soldering iron, also known as a soldering station, it's got these little alligator jaws, and I don't use these alligator jaws too frequently, but every once in a while they can be really useful for holding something in place. So I'm actually going to use it now. Wants to flop around. Maybe that isn't going to work great. I guess one thing that we could do though is I can hold the board in place. So notice how it's just kind of, you know, resting in the air there. And we're letting gravity do the work of keeping the board where we want it to be. And it's not like perfectly where we want it, but it's close enough. And so now we can go ahead and solder just one corner. And I'm doing it from the underside, so you can't quite see it from the camera's angle. But I've got just enough solder in there that it's gonna stay put now. See that? It's not coming loose. Barely enough solder. And now we can go back over it and get the rest. Get this thing out of the way. Also, hold on just a second. I've got a bunch of wires that are kind of in my way, and get those out of the way so I don't damage anything. My soldering iron. Got my Velcro. You can buy these at like your supermarket or office supply store. I recommend that you always have like 2 more unopened packets of these like at all times. I'm starting to run low, so I need to go buy another one. But yeah, I love those. They're on everything. I'll just carefully secure the cabling for my camera so that's not going to get soldered to death. And then, oh yeah, and then let's out of the way. Just kind of flip that into place. Okay, so let's see, we're part of the way through this IC, so let's go ahead and finish it. Double check that it's still in the direction I want it to. I'm also going to reflow this first lead. Remember that when I started it, I barely put enough solder to just kind of keep it in place. So now we want to go back over it. Oh, that stuck for a minute. There we go. Going back in to fill every other hole. Here we go. Okay, second socket is done. Let's do the third one. Let's see, and that worked well at times. Let's do it again. They're gonna stay? Yeah, good. And you know what? Since I've got it all attached here, I'm gonna go ahead and do the corner of this other IC at the same time. Yeah, it's going away. That's, oh, that one didn't quite stick. Let's try that again. Okay. Put. Yeah. You know, I just did something that you want to avoid, and I want to show you what that is. So I just created a cold solder joint on this IC. So the 2x4. So notice this bubble right here on the corner is not shaped like a cone. It's just this big blob. And the reason for that is because the lead, the wire that's connected to that socket, did not get hot enough. And so the solder didn't fully connect to it. This is bad. So look for little bulges like this, and you want to reflow these. Now, we have to do the other 4 so that it's going to stay in place, and then we can reflow it, but watch for that. Okay. We'll check. Yep, that's going where I want it to. Reflow that. And I just reflowed that first corner. Okay. Oh yeah, so I see socket number 3 is done. Now we gotta do number 4. That's right over here. There's that cold point. Double check that's, yeah, it's down in place where I want it to be. And now I'm gonna reflow that cold solder joint right here. Go. Looks like a little bit too much solder on it actually, so I'm gonna pull some of it off. Go. Clean. All right. That 4th IC socket is now complete. Nothing to snip off, but everything's in place, so that looks great. Now again. And let's see, if we go back over here, we've just done this step. Tail header pins. Okay. Notice how this is on the opposite side. So, grab these out of the bag. And then we'll need the other eventually. All right, so that's gonna go in here. We're gonna solder in the shorter side of these, right in here, and then the female headers are gonna be soldered into this other PCB right here, and this is gonna be the thing that lets us connect the two. Okay, I think we're gonna want to use the clip again. And this thing is going to really want to get soldered in off center. Like, see, it's kind of floppy. So I think what we'll do is we'll put just a little bit of solder on it, and then we will heat it up and reflow it as we push on it, and we can force it into the position we want. Let's see. I'm going to do just one joint right in the middle. Place, yeah. That's staying put now. But at this point, I can just pull it right off. Oh, if I reflow it, what I'll do, I'll actually put these in. There we go. I think it's, yeah, it's like just a little crooked. Might be kind of place. There we go. Okay. Yeah, that looks better. So you can see the headers in place, at least this set of them. And it's connected just barely by one lead. Now we can go in and solder the rest of them. Let's see, I'll zoom in. And I will get this out. Okay. Make sure that still looks good, still aligned the way we want it to be. This is what the instructions were talking about when it said the parts were a little crowded. Those electrolytic capacitors are making it kind of hard to do this step, but not too bad. Gotta get a good angle. Okay, so we've done basically every other. Go back in, finish them. That's all that. And yes, those all look clean to me. Cool. Okay. So now there's another set of headers that needs to go in. Right over here. Let's see. Same drill. This one's being grumpy. There we go. Kind of a mess, but only just need it to kind of... Now we can take headers. One of the reasons why I'm using the email headers right here, it gives it a little bit of a buffer so I don't get burned. All these components heat up. You kind of hurt yourself if you're not careful. Okay, this looks good. So these are aligned with each other. It's in place. We can reflow this one joint, but I think that looks lined up. There we go. Just double reflowed that first joint. Real silly. There we go. Okay. That's been done. Now you can see we've got our headers, we've got our diodes, capacitors, IC sockets. This board is almost finished. Let's head back over here. We just did this. Male header pins. Now for the resistors. Okay, we populate the resistors, insert each one into its appropriate spot, carefully flip over your board, solder, and clip its excess leads. Okay. Now, one thing you'll notice about this, notice how the diodes kind of lay flat across the board. We've got the two leads poking in. These are different. So one side is kind of standing straight up into the air, and then it's resting like on the component, sort of. They're standing up sideways. It's a little unusual to do these, but again, the instructions said this is kind of crowded on this board. So this is one example. Yeah, so let's go ahead and do that. We need to be really careful to get the right values in the right places. So that's what we're looking for right now. Okay, and I think the way I'm going to do this, so I've got my bill of materials just off screen. What I'm going to do is I'm going to start with just the 100K, and I want to get those out of the way first so that I know that those are complete. And then there's just a big list of all the 1K resistors. You can knock those out. So again, this is R2, R4, R12, and R13. Cool. And then if we look over here, it's these first four that have the orange stripe. These are the 100K. Grab these. R2. And you know what I'm gonna do? Yeah, I don't wanna be thinking too hard about the cameras. I put these in because it's easy to mess these up. So I'll kind of bend it into shape like this, and then I'll poke it into its place. This is R2. Yeah. Triple checking. You don't have to orient the component a particular direction, so you'll notice like these two stripes are going opposite of each other, the orange stripes. That's fine. You just got to make sure to get the right value in the right place. 2, R4, R12. Is over here. And then R13. Okay, so we got these two in the right places. We bent the legs so that they will stay put, and now we're ready to solder them. Okay. Now that I have done that, I can zoom in. Okay, first two are done. Let's reflow this guy. Okay. Got all those in place. They're all soldered. Oh, sorry. That was all off frame. Hey, I snipped off all the leads. So, okay, we got these 4 resistors in place. Now we're going to go ahead and knock out the other ones. So, boom, here's all those. And we're going to do those assembly line style as well. It might get a little crowded if we do everything all at once, so maybe let's do like the, I don't know, I think I'm going to do the top 4 and then we can go from there. Bending these into a good position. They're ready to go in. Good. Bending the legs so they will stay put. Go. And we can solder these 4. Yeah, that's starting to get a little hard to work with that inner. Maybe we'll skip every other one. All right, so we got those 4 in place. They're going kind of different directions, which looks a little funny visually. You can bend them a little bit into place if that is like a thing that you're interested in, but it doesn't matter too much. Sometimes it does matter if you've got like PCBs that fit very close together, then it's usually your capacitors that really matter. Like you got to get those just the right place or else your kit doesn't fit together. Right, we're putting stuff into place. Notice I'm skipping one horizontal row of resistors right there. Kind of keep it out of the way. Okay, we're ready to do those. You know, we can, yeah, I don't know, knock out one more. Okay, double check each of these. I want to add just a little bit of solder to this feed. Cool. All right, we got that batch cleaned up. That looks nice. And now, as far as resistors go, we're on the home stretch. And one note on resistors, like, this might seem like a lot, partly just because, like, we're on a stream and there's a fair amount of, like, repetitive tasks going on right now. This is actually kind of one of the lighter ones. We got lucky because there's only 2 different resistor values. So there's like 100K, and there were, what, 4 of those? And then the 1K, and there were a bunch of those. Some modules, depending on what they are, there might be much more resistors. So I actually did one synth module that was a 6-channel mixer. Excuse me, and super useful module. I use it in every patch, like all of the audio flows through it. But it had just an enormous number of resistors. I think it was something like 100 or 120 different resistors on different, different PCBs that all stacked up. A lot of different like varieties of resistors, and that took a lot of work. That took, I don't know, that build time was, I think I had to do it in 2 or 3 sessions. It probably took something like 6 hours total. This one's taken a little while just because, like, I'm talking through it all and kind of making sure that y'all can see it. You can all, like, see what I'm doing. I normally work faster than this, but yeah, that module was pretty intense. I think I might, you know, if I were to go back in time, I might purchase that module. That module is by an awesome synth company, though. So if you're into Eurorack, Bifaco is the name of that company. They're out of Spain, and they make fantastic DIY modules. I think I've done 2 from them so far, and we've got very thorough instructions, and like they're just kind of high quality, no nonsense type of modules. So yeah, can definitely recommend them. Some of the other like DIY companies I can recommend for synths in particular. Synthrotek is fantastic. Let's see, another one is RYO, or Ljunggren Audio. They're based out of Sweden. Synthrotek, by the way, is based out of Idaho, USA. Just up the road, you know, from where I'm based in Utah. You know, up the road meaning like 3 or 4 hours away. But yeah, so we like Synthrotek. Let's see, what's another good one? 4MS has a couple of cool modules that are very useful, that are metronome related. And another absolute like classic synth DIY company is Music Thing Modular. Let's see, they're based out of somewhere in the UK. I'm not sure where. But they're awesome because they've got kind of these hybrid analog digital modules that can do a lot of different things. One of their modules is called the Touring Machine, and I disagree with the naming of Touring Machine, because if you've studied computer science, you know that Turing Machine is just sort of this general abstract idea of a computer that does things, whereas the Turing Machine module for Music Thing Modular is a randomness synth module, which does like looped randomness and has a bunch of like expander modules. But despite disagreeing with the name, it's a very cool module. I don't own it, but I've seen videos of it, and someday maybe I'll get it. But let's see, the other one that they've done that I have a copy of is the Music Thing Modular Radio Music. Radio Music is cool. It's actually a teensy, so it's, you know, one of these guys. And by default, it's programmed to be like a sort of an emulation of like tuning the radio. So imagine if you had like your synthesizer controlling the dial of an FM radio, and so you could switch back and forth between different channels. This is kind of the same idea, where you've got like long clips of audio that are in WAV files, and then you can use your synth to control like which bit of audio you're listening to. And so that lets you create, like, if you're familiar with kind of 1940s and 50s era musique concrète, kind of like early experimental electronic music. That's a fun module that lets you kind of recreate that genre and that style. Okay, yeah, I think this is looking good. We've got all our resistors in. They're snugly in place. We clipped off all the extra leads. Yeah. Okay, let's go back to our instructions. Let's see. Resistors. Power header. Sweet. So it's this guy. Yep. Get it flat. Let's see. That should be in the bag. There it is. See this little notch on one side that matches up with the notch on the physical component. That. Let's see, zoom out again. Bear with me while I do that difficult first leg. Maybe I can get it on screen. I don't know. On. There we go. Yeah, and that's situated how I want it. Here we go. Solder stuck to the piece just for a minute. Reflow that first corner. All right, double check that. I think I want to reflow just one of these points. There we go. Okay, so we've got our power supply socket in place. Did our resistors, did our power header. ICs, okay. Carefully insert the ICs into their proper sockets. You need to slightly bend the legs of the ICs inward so it'll fit, yeah. Inserting, make sure to align the notch of the IC with the same notch of both the socket and the board. Don't damage them. Okay. Turn back over to here. Okay, so what I am looking at right now, I've got the bill of materials up again. Notice how it's 3 of the exact same integrated circuit. It's the TL074, which I think if we looked it up, it would be a dual or a quad op amp. So that's doing its thing. These are all the same, which means we can just grab them out of here and we don't have to stress about like which one we're picking. Any of them will work. We do, of course, need to make sure that they're oriented correctly. So we can do that. Okay, notice the oops. Notice the notch on this guy. You can see it down in here. That's the notch that needs to align with this stuff in here. There we go. Yeah, I think we do want to bend these. You want to be very gentle, break them. One thing that you can do is you can put one side of legs into the socket and then gently push and it'll bend all of them. Okay, I think these are ready. Good. Oriented correctly. Now, carefully push that down into the socket. Oh, and I'm expecting it to go a little bit further down, but maybe we're good. Yeah, it doesn't seem to want to go any deeper, so I think we're good there. Cool. That's our first IC. Let me check one thing really quick. Let's see. We'll grab this second IC. You know the drill. We're going to orient it correctly. Carefully bend those legs into place. Putting just a bit of pressure on them. Feel like they haven't gone quite far enough, so do it a bit outside of the socket as well. Okay, ready to go. Get it aligned. And then gently get it in place. There we go. Okay, doing the third one. Lines with that notch. Get it started. And that. Yeah, and this is the socket that has the one kind of weird lead on it. So see how this goes. I think we might be good. Give it just a little bit of extra pressure. Oh, okay. A little bit of, there's a little click that's into place. Yeah, so I think that's good. We might actually want to do the same thing here. The pressure. Get that into their houses. Click. There we go. Okay, so those three look good. And then we'll do this one smaller one. Okay, now notice here. This IC does not have a notch in the middle, but it does have this circle on the corner. So we should be able to match up this circle with what we see in the picture. If we come over to here, Notice how there's the notch on the left side, and then on the bottom left corner, that's where we've got the circle. And then we can see like the Texas Instruments logo on the top. So, should be aligned like this. We will just carefully set this in here. There we go. And these are quite a bit easier to fit in than the big one with 7 legs on each side. 1, 2. Yeah. The 14 leg. Okay. There we go. Put all those in place. Let's run back over to here. Do the ICs. Control board. Okay. Awesome. This is really good. So we've done all the small, intricate, hard stuff at this point. Now at this point, like, this is the really fun part, because this is like the interface where it's the audio jacks and the switches and the knobs and like everything that we actually interact with when we're playing the synthesizer. So things are going to get real fun now. I guess some of this like is still headers that like plugs the front PCB into the back PCB, but you get the idea. Okay, well, yeah, let's do it. Move over to the control board. Add the headers. And we know how to do that. Okay, we do need to make sure it's oriented correctly. So grab this. This is the second PCB here. Get it out of its bag. Okay, so the jacks are going to go on this side, headers are going to go on this side. And I'm looking at the picture right now. It looks like we want it that direction. So put that aside. It'll look like that. Yeah, you can see the smaller headers go over on the right side. Okay. We've done on some of those other headers where we'll get it to just barely stick and then we'll fix it afterwards. Okay, that is how we want it to be. Oh, it's a little crooked direction. So let's just get this other side here. Okay, cool. That's yeah, it's not perfect, but it's like close enough it's gonna fit fine. So go ahead and solder each of these leads. Okay. Smaller one. We gotta get the big frustrating one. Okay, there we go. Get that first lead in, that's going to stay put. Get those other leads soldered. We have half of the leads done. Cleaning off the soldering iron. Blow that first lead just a bit. There we go. Cool. We've got our big mess of leftovers right here. All right, so let's head back to the instructions. Email headers, pockets, we did that. Standoffs. Okay. There's one. And then here is the other. Come on. Here we go. And then let's see, we need that screwdriver. Give me a sec, I gotta grab that. My smallest screwdriver bit is so tight in there it's not coming out, so I'm using the pliers to pull it out. There we go. Okay. So let's see, here's that screwdriver. Double check that this will fit. That is tiny. Yeah, that should work though. Right. All right, so we want it to be going up the same direction as the headers. And remove the screw from one side. And my goal is to not lose that. Okay, so I've got it started now on this side. The rest of the way. And it's really pretty tight against the headers right there. Snug now. Now we have the other one ready to go. Oh. A little more freestanding, so it's easy to get it out of the way. More machine tight. Okay. Those are both snug now. I think we can just keep the other two screws in there for now. We added the standoffs. Now we're going to add the jacks. Yeah, notice this, do not solder yet. We want to get the front panel on first and then making sure that everything like fits snugly. Better not to put the panel upside down. 5 pin. Ah, this is good knowledge. Okay. See, there's that. I'm gonna take just a second and clean up the workspace a bit. I want to have the faceplate ready to go. Okay. And then we've got all the jacks ever. And we need to take the nut off of each of them. So that will take a bit of time as well. Do. Oh hey, I'm not quite in frame once again. This is my first stream trying to do work with my hands and like have a top-down camera. I think it's been going okay. So thanks for giving this a try with me. I think we're learning good things about when and how to zoom the camera and like where the workspace is at any given time, and I've like crammed all of my like normal computer stuff, my keyboard and mouse, kind of off into a corner, and so there's probably some smarter way to organize that stuff. So yeah, this is a good learning experience. Each of these nuts is going to go on over the faceplate, and that's going to help secure the module in place so that nothing rattles around or slips off or whatever. Hey, maybe that's a faster way to do this. Kind of flick it till it falls off. Okay, those are all ready to go. I've got to orient this the right way, so I'm looking at the instructions on my screen right now. Once the board oriented like this, and then the first two go cool. The directions of these jacks kind of alternates. Or maybe it's just with these first few. Yeah, because then it looks like a bunch of them go. Last couple point the other direction. And then everything else points downward. Making the picture, this still looks right. Pull off that first one just to double check that's facing the direction I expected. You can see right here, you got like plus, and then the circle kind of connects at that lead. So that's how you know it's pointing in the right direction. All right, we've got each of these in place. Now let's see, that's still pointing in the same direction. And we want it to go like... What does this say? The 5-pin socket on the control board right here. Go under inputs 1 and 2. Yeah, okay. Yeah. That all fits. And now we're going to put on just a few of these. A few of these nuts to keep everything in place. Oh. Or does it want us to do all of them? Maybe we should do all of them. I like to do this part kind of from the diagonals. And it gets it started, it's held in place. And we're gonna get each of these nuts sort of finger tight, and then we will go back and tighten them again. Getting these all on is quite meditative. By meditative, I mean tedious and kind of frustrating. The thing that makes these tricky is it's easy to misalign the threads so they don't go on. There. You can see how like I can hold it kind of loosely and the whole thing doesn't fall apart at this point, which is good. There's enough kind of pressure going in different directions that it holds itself together. And this way we also know that the parts are going the directions they need to go, so we can solder it all. Yeah. Last one, and then we can get everything tight, like tight-ish. I'm thinking we can go back and use the pliers to tighten these after everything's soldered. I think everything is finger tight at this point. Yeah, good. Okay. Let's head back over to the instructions. Once the front panel is secured, flip the projects over so it's resting on its jacks. Gently push on the back so the port is flat and straight. When the panel and PCB are aligned and straight, you can solder up all the jacks. Let's see. I'm nudging some of these in place. Some of these have rotated just a little. I'm just kind of rotating them. They're square. Okay. Ready to do that. Now, let's see, I haven't used the iron in a couple minutes. My iron has a cool feature where it'll sleep if it's been resting for a while. So it'll actually cool back down to like just 100 or 200 degrees, something like that. But then it needs to be heated back up and needs to be cleaned again. So that's what I've just done. Now the tip should be ready to use again. Not totally clean. Another thing that I can do is actually soldering tip cleaner. That you just kind of scrape it through there. It's like steel wool, but that tip is cleaner than it was. Yeah, so that's ready to use again. All right. Yeah, we've got a lot of jacks that we can solder. So some of these leads are intentionally connected together, which makes sense because you're copying and pasting an input to 3 different outputs. You know that that signal should be identical. So that's what's going on with these 2 leads right here. You can see it on the opposite side too. Like these 2 are like the silver's actually touching on both of those. Now these jacks actually have legs that are not they're not cylindrical. And so soldering those works a little bit differently. Sometimes you end up like moving around a little bit in order to get it flowed all the way around. But it's not too different. Making progress. About finished with this side. Good. There's that first side. Double checking each of these joints. Yeah, I think these look good. And now let's do the other side. Generating a lot of smoke here. Kind of fun. I want to double check something here that I didn't. Yeah, okay. I didn't create what's called a solder bridge. There is a very clear solder bridge right here where there are two leads that stick up, right? And I've bridged between them, like the solder connects to both. But remember, that's just fine because the leads themselves were also connected. So this is expected. None of these should have bridges though, and they don't, so we're good. Here's another tensional solder bridge. All right. So we've done it. This is all connected now. Make sure. Good. I think I want to reflow that one. Good. There we go. All right. Yeah, I think that looks good. That is all soldered into place. That actually looks like a synth module now. Okay, let's head back to the instructions. Solder up all the jacks, so we did that. Board connection. Carefully connect the main board and the control board as shown below. And then you put the screws in. And then we're done. Sweet. Let's switch back over to our workstation. First screw. And the second screw. I really want this one to stand up, but it won't stay. There we go. Okay, got that ready. And then here's our control board. We'll just orient it the same way. And then we will carefully get those headers together. Push that into place, and then you can see the standoffs line up. Come on. Should be magnetized just enough to come. Maybe not. All right. We're going to use the pliers then. We'll just get it started. That is in place. Do that in the rest of the way. I'm just gonna get it kind of finger tight and then put in the other one so that we make sure we're not like pulling on one direction and not the other. pretty tight. And now that's pretty tight. Okay. My friends, I think we just finished. Got our module from the top, from the front, from the side, from the back. Got all of our op amps and all of our other cool components still in there. Everything connects through these headers. I don't know very much about it, but somehow they're cool normaling circuits, which basically says if you plug something in, if you don't plug something into here, then whatever's in here also gets copied over to here. But as soon as you plug something into here, it breaks that connection, and that's done by normaling. So that's the 4 different resistors are probably helping with that. But yeah, cool. This is assembled. Gonna double check that these are finger tight one more time. Sweet. All right, and now we are almost 3 hours in. I don't want to go too long. But at this point, let's see, I'll switch back over to here. So at this point, we've got our module, we've got our whole synth. We could just grab the power supply for this and just plug it right in. That's a little bit risky though, because there's some possibility that like we might have soldered something incorrectly. We might have put a diode in backwards, or one of the electrolytic capacitors backwards. We might have a solder bridge, right? We might have like a short circuit or an open circuit where we didn't expect. And so if we put this into here, there's a little bit of risk that either we burn this out or we burn all of that out, which is worst case scenario. So instead, what we're going to do at this point is we're going to clean up some of this workspace stuff. And I've got a second Eurorack case that's quite a bit smaller. I call it the lunchbox case for reasons that you're just about to see. And so we'll test it in isolation there, and then we'll put that next to the big synth, and then we can test it there. If everything looks good, everything's working as expected, then we can install the module into the main modular and we'll be finished. So switch over to here. Here's our module once again. We're going to connect the power strip in here, and it forces it to go the right direction based on its shape. That's plugged in here. And we will move some of this out of the way. And I introduce to you the lunchbox. It's also a Synthrotek. This thing's great. I'm actually going to do these little. Oh, here, let's turn off the soldering iron while we're at it. But anyway, there are these little pull tabs that let you split the case apart. We're going to go ahead and do that now. So we can take the lid right off of the case. Oops. And so you can see that this is what the guts of a Eurorack case look like. You can see here's the rack where you screw in each of the modules. But then down in here, this is the power supply. And this is where each of our modules is going to connect into it. And you can probably see down at the bottom, it says stripe, stripe, stripe over and over. So this red stripe at the bottom of our power cable lines up with that. Go ahead and do that and put it kind of in the middle. And just carefully push that into place. It just kind of fits in. And then let's just put this in one side. Yeah, screwdriver size. Yeah. So I'm going to screw this into just one side on the bottom so that it doesn't fall out. There we go. That's tight enough, it'll stay in place. So, next thing we're going to do is a very time-honored tradition. This is called the smoke test. You'll hear people talk about smoke tests in software too. It comes from hardware though. And a smoke test is where you plug the thing in and you see whether or not it produces smoke when it first starts up. And if it doesn't produce smoke, that's a pretty good sign that it's functional. And if it does produce smoke, then that's a really quite good sign that it is not functional. So we're going to do that now. Bumped that camera. We're working in some kind of confined space here. So the lunchbox case has a little power thing that goes in this bottom left corner. You can see it kind of wired through the inside of the case into the power supply. So I'm just getting that ready now. Here's the cable for it. And here comes the smoke test. Okay. Power supply lights up. I don't see any smoke. A lot of modules have LEDs on the faceplate, and so at this point, if it was functional, you would see those start to light up. This doesn't have any real interface in that way, but this is good so far. Like we're not seeing the mysterious blue smoke. So I'm going to unplug this. And now what we're going to do is we're going to switch over here. I'm actually going to move the lunchbox case closer to here, and we're gonna do a real test with audio. So this is the fun part. Now, let's see. I gotta turn off our cool background beats. And then let's see. We're working in some kind of fines. We're gonna swing the microphone out here. So we're sort of close to the synth so when I talk, you'll be able to hear me. There's a monitor down here. We're not gonna get fancy today with sound going direct in to the stream, so I apologize in that way. But for the future, also angle this up just a bit. My frame. Yeah. Okay. So here is the lunchbox case. We're going to gently set it on top of my cheap MIDI controller. But now we're close enough that we can. Are we close enough? Might have to do it up here actually. Yeah, let's. This is not my favorite part. I think what I really need is I need something to set more distance from it. Okay, power supply. Got another power strip over here. Smoke test V2. Okay. See the blue light in there. By the way, if I'm if you can't hear me, let me know. and I can make tweaks to the microphone and stuff. So, all right. So now, got a synth patch all wired up right here. That's ready to test this. So let me turn that on and walk you through what's happening, and then we can actually plug the new module. Okay, cool. So what's going on right there is got a module, Gel Atlantis right here. Very cool. It's my module right here, synth voice. That's making that sound. And I'm actually gonna disconnect this wire. This is going into the 1 volt per octave pitch input of the synth. And so this cable right here is carrying the pitch information to this oscillator. Now I have a second oscillator going as well. If I turn that down, I'm going to turn up the second oscillator. That sounds like this. This is a very different sounding oscillator. The Atlantis is modeled after the Roland SH-101, which is like a classic synth for like house music and a lot of electronic. If you're to like Aphex Twin or Boards of Canada, both of them use it a bunch. But this sound, this is coming from the Make Noise DPO module, the dual prismatic oscillator, which is based off of first name Don Buchla's designs from the 1960s, who was based in San Francisco during kind of the synth revolution that happened alongside the hippie movement in the San Francisco area. And so basically this oscillator is West Coast synthesis and the West Coast approach to building an oscillator. And then this one is a very East Coast Robert Moog style of oscillator. So it's kind of cool. I want to be able to have both of them at the same time, right? So this little guy's going to let us do that. Okay, they're not tuned to the same pitch right now, so let's do that really quick. Okay, so we've got our two notes, and we've got like a really big oscillator now. Now, we can currently we can only have one of them changing pitch at a time, and so we can either do the East Coast oscillator and then drone with the West Coast oscillator, or I love that sound. We can have different pitches with the West Coast oscillator and then drone with the East Coast oscillator. Right. Okay. Now we're gonna grab this pitch output. We're gonna route it into here, and then we're gonna need 2 more cables. Normally I would put those down here, but let's see if this works. Okay, the East Coast one sounds good. Oh, it can't quite reach. And it's working. Beautiful. Okay. Now, at this point, we've only tested like one of the combinations, right? We have input 1 and then 2 outputs nested directly under it. So the next thing that I would need to do is go through a bunch of combinations. Like, does in 1 work? Does in 2 work? Does in 3 work? Does in 4 work? Does breaking the connections with normaling, does that work? Can I do in 1 with like out 4, all that kind of stuff? I'm not going to bore you with all that. I'm going to do that like after the stream is off. But let's just test one over here. I think that'll be good. Yeah. So you can see that's going all the way from 1 to 2 to 3 to 4. And it's working. All right. Cool. I am very happy with that. All right. Let me get situated real quick. We can wrap this thing up. Switch back over here. There we go. Oh, we gotta end with our cool beats too. All right, we have beats. So, my friends, we did it. We soldered together our module, got it right in here, looking great, sounding great. It's behaving the way that we expect. This is awesome. This has been a success. We got to see it, you know, down in here in action. We talked a little bit about the tools that are used for soldering, right? We talked about some of the other like DIY stuff, this kind of stuff. Where did that other module go? Here it is. We talked about like, you know, building modules all the way from scratch, and in the future we'll get to do that as well. I've got at least one idea that I would like to do very soon called the pingable LFO. But yeah, this is great. So yeah, thanks for tuning in. I think the next stream is going to be either this Tuesday, like Tuesday next week, or Tuesday the following week. Thanks for tuning in. Or if you're watching this video in the future, then thank you for doing that as well. Give me a follow or a subscribe or a like, depending on the platform that you're coming from. I would greatly appreciate it. I want to spread the word, get this out to more people. And yeah, thanks so much. I'm Andrew. This is Code Gets Creative. And everybody stay creative. See ya.